Hello, viewers. In today's session, we are going to discuss another important and interesting problem from domain of functions. And in this class, we are going to find out the domain of this function y is equal to square root of logarithm of cosine 2 pi x to the base 10. Right. So here, in order to find out the domain of this function, we are going to make use of some important concepts from functions and trigonometry, right? So let us start. So here we see that we have the square root function, right? And the first condition to find out the domain of this function is that this quantity which is inside the square root sign, it has to be greater than or equal to 0, because we cannot have a negative quantity inside the square root sign, because in that case the number belongs to the set of complex numbers, right? So this quantity has to be greater than or equal to 0, so that the domain of the function, it should lie in the set of real numbers. So the first condition is that logarithm of cosine 2 pi x to the base 10, it has to be greater than or equal to 0, right? Okay, now here we see that the base of the logarithm is 10, right? So now what we will do, we have to solve this inequality for all values of x, that is the valid values of x, right? So what we will do, we'll raise both these numbers to the power of 10, right? So here I will write 10 raised to logarithm of cosine 2 pi x to the base 10, and here we have 10 raised to 0. So raising both these numbers to the power of 10, right? And we see that this base 10 is greater than 1. So here the direction of the inequality remains the same, because from functions we know that the exponential function, say y is equal to a raised to x, is an increasing function for all values of x belonging to r, for a greater than 1, right? So here when we raise both these numbers to the power of 10, then the direction of the inequality doesn't change, because the exponential function is an increasing function for all values of x belonging to the set of real numbers for a greater than 1. So now here this quantity is simply equal to cosine 2 pi x, because we know an important result, that is a raised to say logarithm of p to the base a is equal to p, right? So here the value of a is equal to 10, and p is equal to cosine 2 pi x. So the value of this quantity, 10 raised to logarithm of cosine 2 pi x to the base 10, is equal to cosine 2 pi x, and here 10 raised to 0 is equal to 1. So now we have reduced this inequality to this one, and we have to now solve this inequality using some concepts from trigonometry. So now this inequality says that cosine 2 pi x should be greater than or equal to 1. And from trigonometry, we know that cosine theta, it lies between -1 and 1, right? So here cosine 2 pi x cannot be greater than 1, and it has to be equal to 1, because cosine theta, it lies between -1 and 1, right? So here I will take cosine 2 pi x is equal to 1, because cosine 2 pi x cannot be greater than 1. So we'll retain only the equality sign here. So cosine 2 pi x is equal to 1. So now this is a trigonometric equation, and in order to solve this trigonometric equation, we'll make use of this result, that is when cosine theta is equal to cos alpha, then the general solution of this kind of trigonometric equation is given by theta is equal to 2n pi plus minus alpha, where n belongs to the set of integers, right? So here we have cosine 2 pi x is equal to 1. So we can also write it like this: cosine 2 pi x is equal to cosine 0, because cosine 0 is equal to 1. So now if we compare this equation with this one, then the value of theta is 2 pi x, and the value of alpha is equal to 0. So using this result, the solution of this equation is now equal to 2 pi x, that is theta is equal to 2 pi x. Then we have 2n pi plus minus alpha. Alpha is 0. So here we have 0. So we have 2 pi x is equal to 2n pi, and x is now equal to 2n pi over 2 pi, and we can now cancel here 2 pi. So we are left with n, where n belongs to the set of integers. So we have now x is equal to n. So the domain of this function y, it consists of all the integers n. That is, the domain of this function is given by this set, that is n takes the value 0, then we have plus minus 1, plus minus 2, plus minus 3, and so on. So this set gives us the domain of this function.